Okay, hi. So I'm Robin. I'm also involved in the Obesity Network. As Pablo mentioned, I'm based at the CDRC, which is a consumer data research centre, and it's always been setting out to be at the forefront of big data research in the UK. So this is a great place to be doing this research, and it's been a really great first project to get stuck in with consumer data. But quite interestingly, it's not just using kind of what is traditionally seen as big data. We're actually extracting a hell of a lot more value out of existing, what some people would see as official data sets, and showing it in new ways that adds huge amounts of value to it. So I'm talking more about the technology behind this. I think everyone can begin from the premise that in order to tackle obesity, we need more active travel. That's where I'm starting from. I'm going to talk about the technology of how we can integrate large data sets into our research. So obviously we've been working on a project that's been very challenging in terms of the data for 1 year, and over time I've made various mental notes of, oh, I'd do that differently, or oh, I wish I'd gone back and looked at that. So hopefully this talk will provoke some discussion, and I've got some lessons learned, and I've even got the provocatively titled commandments for big data. So this is what I apply to myself when I'm using what I call big data, which I'm going to define subsequently. And another thing that's quite illustrative of the way things change when you move into this big data context, which is the future of obesity research, I think. I'm an academic primarily. I'm actually starting a position in the Leeds Institute for Transport Studies, so I'm also a transport guy. This is why it's going to be quite focused on transport, even though that has massive health implications which often aren't seen. But my role, my job title in terms of this project is developer, and that's quite indicative of the kind of new ball game that we're in. I'm not only an academic, but I have to develop code and maintain code, and that's been really challenging. So hopefully my experience will be useful to others. So time is of the essence, and I think it's going to be really important to have a discussion, a proper discussion afterwards. So forgive me if I skip through some of these, because I do want to finish on time. Pablo's there, ready and waiting. But I think it's going to be great to talk about some of the experience and use this as an example. So I'm going to talk about what we did, big data in the PCT. James has put it in context, and I'm going to talk about what we actually did from a technical perspective. I'm actually going to show some code, because you cannot escape from code when you're working with big data, and that's going to be one of the commandments of working with big data. And, of course, some lessons learned, which I hope is going to generate some interesting discussion. So James has presented the tool, which I'm glad to say the test server hasn't fallen down just at the time when we need it to be up and running. And I really want to emphasise that anyone in the world with that URL can go and look at the propensity to cycle tool. And that's a big step forward, and that's what is allowing the Department for Transport to engage with local communities much better than they have done before, and actually really encourage public debate. And obesity research is obviously hugely socially relevant. So if we can get our research outside of the confines of academia and into the real world and allow the public to see this kind of stuff, that's going to be massively beneficial.
Do you want to highlight the next main URL for people to go to?
Yeah. So, I mean, I'll do that at the end, I think. It's probably best. So it is a big data project. So as James showed in the map, we had about 50 regions, and that regional geography itself has changed over time. We used lower super output areas, which were way too small, and then we used combined unitary authorities, and then we looked at using CSAGs, which are kind of combined health authorities. Then we looked at using LEPs, but each of these regions takes over an hour to build when we're running the model. So it is a big data project. We're using APIs, which are online interfaces for computers to talk to each other, and we're having thousands and thousands of calls to these things. which is an additional layer of complexity, dozens of file formats, and we're trying to bring all of these different files and sources of information together into a single place. And that is a big challenge. And that, you know, I've been involved in projects where the main way of collaboration is through email. There's no way in hell that you can coordinate this kind of activity through a long email thread. And I think even Dropbox would struggle to do some of this stuff. So that links to how you kind of organise your work. So we started with this massive data, which looks a little bit like a haystack. The project might vary, but big data often looks something like this. You just got a massive data and you can't see, and it doesn't tell a story, it doesn't give you policy relevant results. Over time, we simplified it. So that process of simplification and boiling it down is hugely important. As James showed, we've done route allocation. So we haven't actually done this work. We've sent out those lines to a routing API. We had to write a bit of code that would turn that straight line into a line that's allocated to the route network, and that's added value. Every stage that we go has done something useful. And then finally, some guy, I didn't actually write it, a guy at the University of Lancaster wrote a piece of code that takes all of these lines allocated to the road network and adds them up, which is extremely useful if you want to know about the capacity on the road network to be expected. And that's the results. James has already shown it, but I just want to kind of, I'm going to skip these slides because you've already seen it. What's great about putting all of this into a model, into a kind of overriding framework, is that we can use this data to model. And big data, often it's just about descriptive analysis and visualization, but you have to be able to get it into a format where you can actually run a model on it if it's going to be policy useful, I think, or it can help it be policy useful. So that's what we've done. We can show how cycling would shift in the future. So that's an example of a road network. And then in the future, you can see that the distribution, it's quite subtle, but it actually changes from one place to another. So planners can have that insight to look into the future. So now moving quickly on to the technical perspective, and this is a definition that myself and Mark Birkin have published, and we think that big data is essentially, it's an umbrella term, hence the umbrella down there. It's unconventional data sets that are difficult to analyse using established methods, and this often relates to size, but it's not always just about size. It includes the form, format and complexity, and those are equally important. So I've actually got a worked example here. This is a big data set, and if I were to move that out that way, it would go on for a long, long way, that particular line of text. Can anyone guess what that is? Just looking at it? It's obviously a text file. It's a plain text. It's GeoJSON, yeah. It's Ali. Ali's also a developer and he gets credit for providing this code. There you go, Ali. You've got your credit. So this is actually a URL, and then we use this next line of code to go away and take that code from the internet and put it into a text format. Then we transform it into a GeoJSON list, and then we do this funny line of code, which if you don't like R, you'll hate this line because it looks really contrived. But basically, we're getting rid of all of the mess and we're getting the coordinates out of it. Okay, so what we're going from is this horrible text string that doesn't mean anything to anyone into an interactive visualization. And I know, unfortunately, this map hasn't worked, the curse of the live example, so I'm quickly going to try and see if I can get it because I promise it is online somewhere. So we can actually take it and publish it. So I put this online yesterday just to illustrate how easy it is to get stuff out there now. So it's on my personal site. If I can remember the name, I think it's Leeds. Fingers crossed. So that is what that data is. So this is one story that it tells, and you can see it's actually the train track, the public transport route from Leeds down to Cambridge, and that was produced by the Transport API, which is a new tech startup. And we need to learn to interact with these new organisations. We can't just rely on a single data provider anymore. So that's the point. of this worked example and code. And if I was to try and do that with a graphical user interface, there is no way in hell that I could do that over hundreds of origins and destinations. So that's why I wanted to include a brief bit of code. And then this final bit of code, you use an iframe to embed it. For some reason it's not working. And the command line to copy across the data to some public server, some public-facing server. So these are the kind of techniques that are really useful for big data research. Moving rapidly on, because I know I need to wrap up fairly shortly. But I do have these. I want to get to the discussion and these commandments for working with big data. So this work has implications for obesity research. So it needs big data. It's a multidisciplinary field, and it's taking data from very diverse sources, and that data is going to look like a mess when it lands in your inbox or in your Dropbox file. It's going to be pretty difficult to analyse. It's obviously highly geographically dependent, and there's been some great work in this room by people in this room looking at that. It's also operating on many, many different levels, so it is inherently a big data challenge. And yeah, it's crucial that we can share our work, and that's where just normal data analysis, everyday data analysis, becomes data science, when you're actually doing it in a reproducible way that can handle the complexity of all these multiple data sets. So one option, and there are new methods that are needed for this. So one level are these multi-level models, methods such as spatial microstimulation, where you're taking data at one level and allocating it to another level. And you can also have agent-based modelling in there. So I think from a modelling perspective, it poses new challenges to obesity researchers. And I've just got a screenshot there. I think we can take lessons for other disciplines where they've tried to use big data. So in economics, there's a famous scandal. Psychology, I'm not going to go into these details because I need to hurry up. But basically, this stuff is creating challenges across the board. And I really wanted to point out that now the academic journals are catching up with this. So Nature has said a condition for publication in Nature is that the code and some of the data must be made available. So you must use a reproducible workflow to use large data. And this is moving me on very quickly. I'm sorry, James and Alvaro, who provided these slides, but I really want to get to the key part of this presentation, which is the lessons learned. So teamwork on big projects, they're inevitably going to be complicated and involve multidisciplinary teams, and you cannot rely on large email threads to coordinate your work anymore. Well, hopefully you never did, but version control is necessary. Code sharing and review is going to be important, so you have to learn to read other people's code. Someone can put in code that breaks what's going on, as we've seen, and that has huge potential benefits across the board that I've mentioned already. So we've got new technology for collaborative working. Does anyone know what this is? And not Ali? Okay, this is the symbol that represents forking code in a system called GitHub, which is an online code sharing and file sharing system. And they use like quite funny little cartoons to represent doing stuff. So this shows how easy it is now to take someone else's code and fork it onto your own project. So you don't have to start from nothing. You can find out which organisation has gone the furthest in the area your research is interested in, fork their code and take that and build on it. That's how open source works. We don't need to start from scratch anymore. And that's a really important point. And it links to these 5 commandments that I've come up with. I tried to get 10 commandments, but I thought for the sake of not being contrived, it would be better just to have 5 good ones rather than 10 bad ones. So number 1, thou shalt remember the purpose of thine research regardless of the size of thine data set. And that means that you can actually get lost in big data. There's so much of it that you can forget the purpose. And the propensity to cycle tool is fortunate in that we've had a very clear purpose from the beginning, which is to improve transport planning. Number 2, thou shalt not spend excessive amounts of time making visualizations of big data for the sake of it on social media clickbait. Focus on the objective and don't get lost. Number 3, thou shalt not do big data until thou hast learnt to do small data first. Number 4, thou shalt not hide thine ideas behind complex terminology associated with the terms big data or data science, the meaning of which has not been clearly identified in your research. Number 5, if thou wants to be a data scientist, thou must program. And there's a fantastic article on there which you can find on my slides. And for documentation, sharing, and scientific repeatability, you've got to have a code base, and you've got to know where your code is. So they're my 5 commandments. I hope they're provocative, and I hope they lead to an interesting discussion. So thanks a lot, and I'm going to leave it there. Cheers.
Thank you, Robin. I think we've got time for one question before our next speaker starts. Otherwise, there's going to be time for questions during the panel discussion. Is there one question that anybody's burning to get off their chest?